Good morning everyone, my name is Benyathip Iwanchot. I am studying in Faculty of Medicine at Mahasarakham University. Today I would like to talk about microplastic in Antarctica. As we all know, microplastics have been found in almost every corner of the globe. But what happens if microplastics are found in Antarctica? My presentation is divided into 7 main parts: introduction, evidence of microplastics, origin of microplastics, impact of microplastics, prevention, conclusion, and references. Why Antarctica? Antarctica is relatively isolated and insulated from the rest of the world and has dense anthropogenic activity. Across the continent and the ecosystem are not completely cut off. Global systems interact, but Antarctica is often used as a measure for quantifying the minimum amount of maximum damage that we have done, because whatever is detectable here would typically be much lower than in the rest of the world. Therefore, Antarctica can act as an indicator of physical, chemical, and biological effects caused by anthropogenic stresses. Then, in the second part, evidence of microplastic, the graph shows polymer types identified across all samples. Graph A, number of each polymer type found across all Antarctic study sites. Page was the most frequently detected polymer type, found in 79% of the samples, comprising 41% of total polymers identified. Graph B, number of microplastic fragments and fibers identified in each color category. Film N equal to 1 excluded. Fibers were the most abundant, morphotype 61%, and the majority of microplastic identified were blue 55% and pink 73%. Blue was the most common color of both fibers and fragments. Graph C, size distribution of microplastic across all samples, categorized by morphotype length. A large proportion of microplastics were less than 1,000 micrometers, 81%, with 28% in the 0 to 200 micrometer size length. All fragments were less than or equal to 1,000 micrometers, while fibers were present in all size groups. Next, microplastics in Gen 2 penguins from the Antarctic region. Let's look at the example of microplastics isolated from penguin scales and analyzed using UFTIR. A. Blue polyether fragment. B. Transparent polyethylene film. C. Transparent polyacrylonitrile fiber. D. Mixed polyether fibers. E. Blue polyacrylate fragment. And L. Transparent rayon film. Let's go to the next part, origin of microplastics. Firstly, plastic products in use at research stations, including building materials, microfax, safety equipment, and tire rubber, may fragment with environmental exposure and be a potential local source of microplastics into the environment. Secondly, long-length transport of microplastics. For example, the transportation of particulates such as dust across the Southern Ocean and into Antarctica from other continents, and then transportation of microplastics into the Southern Ocean with deep water processes can also introduce synthetic pollutants from afar. Thirdly, local anthropogenic sources. Microplastic particles may have originated from local anthropogenic sources and been transported along Antarctica via a cycle of entrainment and deposition. Now, I would like to turn to impact of microplastics. Evidence from the northern hemisphere shows that microplastics may impact pelagic ecosystems by causing toxicological effects in key species such as copepods and euphausius at the base of the food chain, as well as potential bioaccumulation and biomagnification through the food chain. In turn, these processes could have negative consequences for higher predators such as fish, seabirds, seals, and whales. Antarctic benthic communities consist predominantly of suspension and deposit feeders with dominant taxa in both shallow and deep water, relying on dehydrated in the water column and sediments to obtain energy and nutrients. It is likely that these species will be affected by deposition of microplastic due to the risk of ingestion associated with their feeding strategy. Shallow sublittoral habitats are highly heterogeneous, patchy, and heavily impacted by ice. The impacts of icicle together with advection result in the resuspension of sediments and potentially any microplastics within them, which may increase the likelihood of them being ingested by benthic taxa in coastal areas. Moving on to prevention, there are several ways to prevent microplastics. My talk will be in 5 ways. First, interception of microplastics using Lonely filters. After that, regulate the microplastic contents of personal care products and cosmetics. Next, improving microplastic retention at wastewater treatment plants. Then, regulate tire abrasion rates. Finally, generating awareness of the microplastics issue for industry and consumers alike. So, to sum up, Antarctica is key to understanding how our world works and our impact upon it. Everyone should highlight the importance of further monitoring both in Antarctica and its surrounding water to develop our understanding of the microplastic footprint in the Antarctica and the threat it may pose to the Antarctica environment. If you have any questions, I will be pleased to answer them. Without resources, my presentation would not have been possible. Thank you for providing these resources. Thank you all for listening. It would be a pleasure being here today. I believe that together we can reduce microplastics in Antarctica.